All right, good afternoon, students. We're going to get started. So I'm going to go through this video fairly quickly and go through these notes fairly quickly. So if at any time you need to pause the video, you can do that, but I am going to roll through it pretty quickly. When you're done taking notes, there should be an assignment posted on Big Ideas, just like we normally do. And so the expectation would be that you show your work in your Spiral notebook and complete the assignment on Big Ideas. All right, so last class we started learning about solving inequalities. Today we're going to talk about compound inequalities. And what I would like you to do right now is to pause the video and spend a minute or two reading through this definition and then kind of looking at these examples to see if it makes sense. Okay, so the big idea with a compound inequality is basically that you are combining two inequalities into kind of one problem or one statement. And basically what that looks like is if it is a statement that has the word and, or it doesn't have the word and, but it looks like this, it's going to end up being a graph where two lines kind of run into each other, and a solution has to satisfy both inequalities, meaning on this first example, it has to be a number that's greater than or equal to 2, but it has to be less than 5. So those are called compound inequalities that use the word and they represent the intersection of the graphs of the two inequalities. The other kind we're going to look at today is our compound inequalities that have the word or, and these kind are the union of the graphs of the inequality. And what they mean is that essentially, generally speaking, you have two lines that are going away from each other, and as long as a number meets either of those qualifications, it can be a solution. So if a number is less than or equal to -2, it could be a solution, or if it's greater than 1, it could be a solution, and then anything that kind of falls in this gap right here would not be a solution. Okay, so let's look at a couple examples. So it says, write each sentence as an inequality, graph each inequality. Example 1, a number x is greater than -8. All right, so let's start with that. A number x is greater than -8. Again, I'm going to start going through these examples really quickly, but if I'm going too fast, you can just simply pause the video and get caught up. So a number x is greater than -8, and it also has to be less than or equal to 4. So this is an and statement. We can combine it into what's called a compact inequality. And I would like you to write compact inequality on your notes. And essentially what that means is we're going to turn these two inequality statements kind of into one statement. The way that you do it is you put the smaller number on the left, you put the x in the middle, and you put the bigger number on the right. And then you just have to make sure that your inequality signs are facing the appropriate variable or number just like they were above. And then the last thing you're going to do is you're going to graph this. And so I'm just going to make a real basic number line. So on -8, this is going to be an open circle. On 4, this is going to be a closed circle. And these are two lines that are going to be running into each other. So I'm actually going to take a step back on this first one. So if I was graphing the statement that said x is greater than -8, well, that would be a line going to the right. If I was going to graph the statement that said x is less than or equal to 4, that would be a line going to the left. But what happens is those lines end up running into each other. And so the solution set means what the solutions are. Those can be anything that is between -8 and 4, essentially, or greater than -8, but less than or equal to 4. So if it's something on this side of -8 or on this side of 4, it would not be a solution. All right, example 2, this is an or statement. And so it says a number y is at most 0. So that means y actually needs to be less than or equal to 0, or it has to be at least 2, which means it needs to be greater than or equal to 2. Because this is an or statement, this is one where you do not turn it into a compact inequality. You're not supposed to do that. So like back here on this problem where it says compact inequality, we kind of turned it into one statement. You do not do that on or statements. Instead, you just leave it as it is. So we're going to go to our number line, -2, 0, 2. Let's see. We're going to put a closed circle on 0 going to the left, and we're going to put a closed circle on 2 going to the right. And again, anything can be a solution as long as it meets either that qualification or this one right here. It doesn't have to be both of them. It just has to be one or the other. And anything that falls in this gap is not a solution. All right, moving on. Actually pause the video, take 2 minutes or whatever you need and try to do these 2 problems. So pause the video. I'm going to do them right now on the video. And then when you come back, compare and see if we got the same thing. All right, so hopefully you had a chance to do these on your own. On the first one that you had to do on your own, that's an and statement. So for those, again, those are the ones that you can combine into a compact inequality. So it should have been 2 lines that were running into each other with an open circle on 0 and 10. On the next one, it was an or statement. And sometimes some of this verbiage that's specifically in this problem right here kind of confuses some students. So the first part of it, a number A is fewer than -6. That fewer than is, of course, less than. But this other statement right here sometimes confuses students when they see no less than. When they see the less than part, they automatically think, well, the less than is simple. But it says no less than, which actually means greater than or equal to. So make sure you're careful with that. And then this is how you should have graphed it right here. All right. Back page of notes, take 30 seconds or so to read this to yourself, please. Okay, so now on the back page, we're actually going to solve some inequalities. So there's a couple ways you can do it. One way, just like we did with absolute value equations, you can turn this into 2 different equations. Excuse me, not equations, inequalities, and you split it wherever the inequality symbol is. That's where you make the split. So on the first inequality, you make the split right here. I'm sorry, let's back that up. On the first inequality, you make the split right here, and so it's -4 is less than x minus 2. On the second inequality, you make the split right here, and so it's x minus 2 is less than 3. And then what you can do is you can just solve each one separately using basic algebra. So for example, on the first one, you're going to add 2 to both sides. I like to always write the variable on the left, so you're going to flip this back around. Because this is a statement that does not have any words at all, meaning it doesn't have and or the word or, it is an and statement. And if it is, it means you can write this as a compact inequality. So if we come back and do that, here's what it would look like. All right, we're then going to graph it. And that's what it's going to look like. Okay, there's a second way that you can solve compound inequalities, and this is probably my preferred method just because it takes a little bit less time and you don't have to rewrite the problems. So in the same way that if you're solving an equation, whatever you do to one side, you have to do to both sides. If you're solving a compound inequality like this, you can also use a method where whatever you do to one part, you do to all three parts. And what that means is I view this problem, I kind of chop it into three pieces here. The -3 is a piece, the -2x plus 1 is a piece, and the 9 is a piece. Those are three different pieces. We can solve for x by doing the same thing to all three pieces. So the first thing you would want to do is subtract 1 from all three pieces. The second thing you'd want to do is divide all three parts by -2. Before I write the next line, I would like you to pause the video and see if you notice anything or think that anything special that might happen in this step right here. All right, well, the special thing that's going to happen here is the signs need to flip because you divided by a negative. So this is a correct answer right here, and if you were to type this into Big Ideas, it would tell you that it's right because it is. But my preferred way, I always want to put the smaller value on the left just because that's traditionally kind of how these are written. And so if you do that, it's going to look like you kind of flip the signs again. You don't really flip the sign per se or exactly like you did in the previous step where you divided by a negative. You're really just rewriting the inequality such that the smaller number is on the left. Now that you've done that, you can go to a number line and you can graph it. So it should be a closed circle on -4 and an open circle on 2. Connect those points and you have your graph. All right, I would like you to pause the video and see if you can solve example 4 on your own. Okay, hopefully you had a chance to solve example 4 on your own. That was an or statement, so again, the arrows should have been going away from each other. All right, we're going to do another couple problems together just to practice. So why don't you pause the video right now and see if you can do this next problem. And I'm going to do it and then turn the video back on. Okay, and we're back. Hopefully you noticed in that one that you do not need to flip the sign because you did not divide by a negative. Final answer should be that. All right, the last thing I want to do here is I want to talk about some special case problems. So right above this, I want you to write special cases. And we're actually going to change this problem to make it more like some of the homework problems you might see today. So here's what I mean. We're going to flip that inequality symbol around. And this is going to be this is a good guide for problems 13 through, I think, like about 17 on your homework. So sometimes you have some kind of special case problems, and here's what I mean. We're going to see how this turns out. So on the first one, we're going to subtract 1 from both sides. We're then going to come back and divide by 2. This is going to say p is less than -4. Or on the other one, we're going to subtract 3 from both sides. We're going to divide both sides by -2. But when you divide by -2, that's going to flip the sign. And so this is going to say p is less than or equal to 2. And so this is going to end up being kind of a weird problem because, as you can see, the inequality symbols are both facing to the left, both facing the same way. So let's see how this turns out when we go to graph it. All right, so this is what this is going to look like. We're going to plot an open circle on -4 going to the left. The other one, we're going to plot a closed circle on 2, and we're also going to go to the left. But if you notice, those arrows are going the same way. And the arrow that says p is less than or equal to 2, that arrow it surpasses the other one, or it supersedes the other one. And what I mean by that is this arrow right here, it covers all of the solutions of the first inequality statement, but it also covers some additional statements, meaning it covers everything that's going to the left of -4, but it also encompasses some solutions that are in between my marks that I'm making on the screen right now. And so here's the point. The solution of this particular compound inequality, it's actually you can just list the p is less than or equal to 2 part, because if you list that as the solution, then that encompasses all of the possible solutions to the left of 2, including the ones from that other inequality statement that was p is less than -4. But it's really, really important to realize that, so while you're going to type this in for your answer into the big ideas box, you cannot, on the other hand, just type this in, because if you just type in the p is less than -4, well, then you miss all of the solutions that are in this region right here. And so if you list p is less than -4 as the answer, that's not going to encompass all the solutions. So you're going to miss part of it, and you're going to miss the question. Okay, so there's kind of one more special case I want to talk about real quick. And let's imagine, instead of doing an entire problem over, let's just say that on the p is less than -4, instead of it being p is less than -4, let's say it said p is greater than -4. So I want you to pause the video real quick. I want you to graph these, and I want you to see if you can figure out what's going on. All right, and we're back. So on the p is greater than -4, if you were to graph that, it'd be an open circle on -4 going to the right. If on the next one, the one that says p is less than or equal to 2, that's going to be a closed circle. I'm going to use a different color here. That's going to be a closed circle on 2 going to the left. So you might be looking at this and thinking, well, this is just kind of like some of the problems we looked at on the front. But it's actually different because remember, this is an or statement. And so the reason that makes it different is because an answer can be anything that's greater than -4, anything in the whole wide world, or it can be anything that's less than or equal to 2. It doesn't have to be both of those things. It just has to be one or the other. Well, if it just has to be one or the other of those things, truly what's really going on here is that your answer, your possible answer, could be anything on the number line at all, as long as if it only has to meet one of those qualifications. There's actually any number in the whole wide world could meet either of those qualifications. In other words, any number in the whole wide world is either going to be greater than -4, or it's going to be less than or equal to 2. So therefore, if you get an answer like this on Big Ideas today, you're going to want to say all real numbers for your solution. And then the way that you would graph it, you're just going to want to graph a line that goes the entire length of the line that they give you on Big Ideas. All right, if you have questions, come see me next week during seminar. Rewatch parts of the video if you need to, but otherwise that's compound inequalities, and your assignment is on Big Ideas.